With this video, I'd like to go over the hands-on exercise that we covered last week. So the first thing we're going to do is just import the modules that we need at the top. So let's go down to the exercise. So the first thing we're going to do is we're going to use the function readCSV that is given to us to read the storm event database for 2019. So we end up with a data frame that has a number of columns. And the first thing we want to do is we want to look at the storms that were in the database. There's a couple of ways we can do this. First, we can treat this as an array, so we can get the shape, but it's a bit easier to actually use the length. And assuming that we have the number of rows is larger than the actual number of columns, that should give us the right answer. Then we need to find two ways to select the location column. First of all, we can think of the data frame as a 2D array, and if we use the standard brackets to index the array, the first thing we can do is just provide a single argument inside the brackets that will give us the column. Now remember, in arrays, when we just provide a single argument in the brackets, we get a subarray, which usually corresponds to the rows. In this case, though, we get the columns. Now, something that's a bit more explicit is using the lock keyword, where we can provide the two indices. So in this case, we use the slice operator to select all the columns, and then we use the location string to get the labeled column. Now, in order to find all the rows where the azimuth is north, what we can do is we can use conditional indexing with the lock keyword. So again, we are explicit in the 2D indexing, and for the rows, we just get the result of this operation here. This one, essentially what it does is it takes the azimuth column, which is essentially a sequence, and checks to see where it's equal to north. Now this will return a sequence which has true or false depending on where the condition is true. So by having true or false here, we can only select the rows where azimuth is north, and then we can get all the columns, or we can select a single column, it doesn't matter. So you can see here that we get about 7,500 rows compared to the almost 51,000. Now converting the azimuth data to true north-based angles, what we can use is something called a mapping. So we want to map the values from north, northeast, and so forth to actual angles. And this can be done in a few ways. So we can either iterate through the keys here and find out the rows where this is equal to each of these values, and then reset as we would do with arrays. But Pandas offers a different function. So Pandas offers this function called replace. So what we can do is we can say replace, and because we want to replace specifically in the azimuth column, we provide a nested dictionary. So the nested dictionary, at the first level, the keys will correspond to the columns we want to replace data in. And as values for that key, we provide another dictionary that has the mapping of the values. If we just provide the two angles dictionary, then it's going to replace everywhere it finds n, and e, and so forth. So regardless of the column, if it finds this value, it will replace those the mapped values. But if we want to be more explicit, we can use the azimuth, and you can see that it actually worked. So now if we try to find all the rows where range is greater than 2 and location starts with the letter C. Now the key here is to find, first of all, we use conditional indexing again, and we find the range being greater than 2. But then we use the ampersand, which constitutes the Boolean AND. Remember, sometimes when we had scalar values, we use the actual keyword AND, but with sequences, it doesn't really work. So we're gonna use this operator here. Now, for the location starting with the letter C, we can use a set of methods that are part of the attributes of this object, the column object. And the same way we did this here, where we check to see where it's greater than 2, we can use string methods that again are contained within it's a module within the sequence itself. Then we can test to see whether it starts with C. And by using AND, we're gonna have both those conditions return true if they're both true. Then we can get all the columns, and you see that we get everything that starts with C. Now, if we convert the azimuth from degrees to radians, again, we'll use this version of the storms replace, and this time just to see the difference, we're just going to use replace 2 angles, the dictionary here, and with this now we can take the azimuth column, there we go, and then we can just perform the numpy operation as usual. So then let's create a new data frame that contains only the rows with an odd index value. So we have the index. You see that we're getting 0 to all the way to 50,833. So we want to find if it's actually an odd value. And with that, you remember we have this operator here that gives us the modulus. So if we divide by 2, if we get 0, it means that it is even value. If it gives us a 1, it is an odd value. So this will give us true or false depending on whether it is an odd index value. So again, we can use the lock keyword, we select the rows, and then we select the columns. And we should get about half. Not about, we will get half of the rows. Now we can delete all the rows with a south azimuth. And again, we use conditional logic. So you see here that we have, let's see, we can use again the lock keyword, storms azimuth equals south. So we can either use the del keyword, which is destructive, or what we can do, we can just filter out, and we can replace the storms. If we want, we can replace the storms data frame with this new data frame. I'm just going to leave this as is, so we actually can keep the original data frame. Okay, delete the location index column. Again, we can use this with, we can do this with the del keyword. But the other thing we could do also is select everything but the location index column. And for this, I want to use a list comprehension. So one thing we need to know is that, for example, we can select all the rows, and then if we want to select multiple columns, we can pass a list. So let's say that we want the event ID, and then we want the range. So we get both columns. Now this list, we can use a list comprehension to dynamically generate something. So for example, we save C for C in storms columns. But now, if we do this, we get all the columns. But in list comprehensions, we can actually add a conditional. If C C, which is again the variable we use to iterate over the columns, if C is not equal to location index. So now this list comprehension will return a list of the columns if they are not equal to location index. And you see the location index disappeared. So you can see how powerful list comprehensions can be, because now we can build all kinds of complex expressions to select a subset of the columns. So now let's find the months that had a northwest azimuth. And for that, we see the months are encoded here in the year month column. So the first thing we need to do is select the rows where azimuth was equal to northwest. And then we're going to grab not all the rows, but just the year month. Okay, we have this. Now we see that this is an integer here. So there's a few ways we can get at this. First of all, we can convert into a string and then grab the last two elements here. The other thing we can do is, for example, let's subtract this. There we go. So a little bit easier. So this will give us the month. Again, depends on the encoding that they're using. What are the average latitude and longitude locations? As you can guess, we because each column is a sequence and it uses NumPy underneath, we have access to all the functionality that's within NumPy. So with that, we can actually do this. Again, here it's a series, but essentially it acts like a NumPy array. So we could just call the mean function, and it will give us the average latitude. We can do this. We can create all kinds of summary statistics. For example, here, if we're looking for the variance of the range of the storms, again, here we've got the range, so we can calculate the variance. Now, what month was the maximum range observed? So this one, for example, we can see, let's see, the range here. Now, if we want, we can get the max. We can also get the argmax, if you remember. So that gives us the index, but the number index, so starting from 0, not this index here. So this is something we need to be cautious about. If we use any of the NumPy functions for indexing, it's going to give us the index, not the label, but the actual index of the array. Now in this case, they will coincide because the index starts with 0. But if we want the label, we're going to use idxmax. But if we want the actual index, we use argmax. And for that now, we essentially do storms year month, and then because it's a series, we can use this single argument in the index to grab the specific row, and with that we can apply the same trick as before and get the month. And then lastly, we'll look at the toCSV function to save a new CSV file. So let's go here. We see we do a tab completion. There we go. So let's look at documentation. So you see there's a bunch of arguments. The more important one is this path here that will give us the file name that we want to save our data frame to. Now, the one thing we need to do here is only select the storm events north of 42 degrees. So before we use the toCSV, and this will demonstrate the chaining of functions, we use the lock keyword, so we can get the latitude greater than 42, all the columns, and this is where the chaining happens. We add another dot, and then we storms north, of to CSV, and there we go. And now let's actually look at the file. There it is. So this is what's been written out. Alright, so hopefully this was clear, but do let me know if you have any questions and post them on the forum, or set up a meeting for office hours.